To display categorical data, we can use either a bar graph or a pie chart. But how do we display quantitative data? In this section, we're going to look at several different types of graphs that can be used to display quantitative data. The first one is the dot plot, which we've already used dot plots for some of our activities this year. In dot plots, each dot represents a data value. So we are making a big switch here. We're changing over from categorical data to quantitative data. So, big switch, categorical to quantitative. Now remember that the purpose of making graphs is to help you understand the data and to see the big picture. So here are some strategies for interpreting graphs of quantitative data. Look for the general pattern and striking departures from that pattern. Describe the pattern by its shape, center, and spread. An important kind of departure is an outlier, and that's an individual that falls outside the overall pattern. So when describing the distribution of quantitative variables, what characteristics should be addressed? The overall pattern and departures, shape, outliers, center, and spread, the SOCS. Okay, so AP tip here is when you're describing the distribution, to get full credit on the AP exam, you need to address the shape, outlier, center, and spread, the SOCS. Make sure you hit all of those. So briefly describe each of the 4 important characteristics of a distribution of quantitative variables. Starting with the shape, we're looking for any peaks or valleys or anything about its shape. Is it symmetric? That sort of thing is what we're looking for as far as the shape goes. An outlier is something that falls way out, it's an individual that falls way outside the overall pattern. So we're looking for something that is outside of the pattern. So the outlier is an individual value that falls outside the overall pattern. The center is a point that is about half, where about half the data are above and about half the data are below that point. And that is the median. The spread tells us how much variability there is in the data set. And this is really the range. Okay, so again, SOCS, shape, outliers, center, and spread. Here is an example. Here is the estimated battery life of each of 9 different smartphones in minutes. Make a dot plot of the data and describe what you see. Okay, so we're going to describe the shape, center, and spread of this distribution. Are there any outliers? All right, there's a peak at 300. Okay, the distribution has a long tail. That's this going out here to the right, and this is called skewed to the right. The tail is out to the right. All the data is over on the left. So it's skewed to the right. The center, or the middle value, is about 330 minutes. The spread is from 460 minus 300 would be 160 minutes. Outliers, there is an outlier. One phone, the HTC Droid, at 460 minutes, had a really long life. When we describe the distribution shape, concentrate on the main features. Are there any major peaks? Not minor ups and downs. We're not going to be looking at those. Look for clusters of values and obvious gaps. Clusters of values, obvious gaps. look if it's roughly symmetric or there's a clear skewness. There's our skewness right here. Okay, so we're going to briefly describe and illustrate the following shapes. Symmetric. The left and right sides are roughly mirror images of each other. In the real world, distributions are almost never perfectly symmetric. They're just roughly or approximately symmetric, and that's what you're going to be looking for. Skewed right means that the right side of the graph is much longer than the left side. The tail is stretched to the right. This is right skewed. Skewed right. If you notice, the tail, this side of the graph is much longer. Right? That is skewed right. Okay, so the left side of the graph is much longer on skewed to the left than the right side, and the tail will be stretched to the left. So most of the data would be on this side, and the tail would be stretched out to this side. Be more condensed over here, stretched out over here. Unimodal is having a single peak. So this is a graph of a unimodal. It's got one peak. So bimodal would then have two clear peaks. And uniform means it has no clear ups and downs. So notice that I highlighted clear on here. These aren't just little tiny things. We're talking about clear peaks, no clear ups and downs. Now would be a good time to stop and check your understanding on page 31. Okay, so let's check this. Describe the shape of the distribution. Okay, it's skewed to the right. Describe the center of the distribution. The median is 1.5 and the mean is 1.75. Describe the spread of the distribution. The number of siblings varies from 0 to 6. Identify any potential outliers. Well, there's two potential outliers, and those are the students reporting 5 and 6 siblings. Okay, big AP tip here. There are two common errors that students make when comparing distributions. They forget to address all four characteristics of the distribution. So think SOCS. They don't explicitly compare each characteristic. You need to compare using words like greater than, less than, and about the same as. So what is the most important thing to remember when you're asked to compare two distributions? Make sure that you address all four characteristics and two, compare. Okay, so address all four characteristics and compare. This example, how do the annual energy costs in dollars compare for refrigerators with top freezers and refrigerators with bottom freezers? The data below is from the 2010 issue of Consumer Reports. So we can compare this data. If you look at the refrigerators with top freezers, all of this is bundled together. It looks very symmetric. So we're looking at a symmetric. Now remember that it's not going to be exactly, because in real world data it's not going to be perfectly symmetric, but it is pretty close. You can also see that there are no outliers here in the top with the top refrigerator. We have no outliers. The center looks like it's approximately at 56, so we're looking at the center. The spread looks like it is, maybe from 48 to 68, somewhere in there. Now looking at the bottom, refrigerators with bottom freezer. looks like this is unimodal. Look at this. Right? And by the way, that is the mode, sorry. That is the mode. It also looks like it's skewed to the right. You can see that long tail coming out to the right. And we've got at least 2 outliers out here. The center, just looking at it, is hard to tell, but I would say it is probably somewhere right in here, which would also be the median if it were. And the spread, this is way spread out. It's going from somewhere around 48 to maybe 150, somewhere around there. So it's very spread out. Okay, another graphical display for fairly small data sets is a stem plot. We also call this the stem and leaf plot. The most important thing about the stem and leaf plot is the key. You have to tell what this represents. Okay, so a stem and leaf plot looks like this. These are the stems. It's very important that you have a key. In this case, the key says that 49 represents a female student who reported having 49 pairs of shoes. So, this is a stem, these are the leaves. That stands for 13, 13, 13, 15, and 19. It's very important that you have the key. So what is the most important thing to remember when making a stem plot? The key. So make sure you remember the key. It would now be a good time to stop and check your understanding on page 34. Be back in a minute. Okay, so we're going to write a few sentences comparing the shape, center, spread, and outliers. So in general, it appears that females have more pairs of shoes than males. The median report for males was 9 pairs, while the females' median was 26 pairs. The females also had a larger range of 57 minus 13, which is 44, in comparison to the range of the males, which was 34. Finally, both males and females have distributions that are skewed to the right. Though the distribution for males is more heavily skewed, as evidenced by the 3 likely outliers, 22, 35, and 38. The females do not have any likely outliers. The multiple choice. The low outlier is Alaska. What percent of Alaska residents are 65 or older? That was B. Ignoring the outlier, the shape of the distribution is, again, that's B, roughly symmetric. The center of the distribution is close to, and again, that's B, 12.8%. All right, happy homeworking. If you have questions, see Miss Hines or myself. Have a good night. Bye.